Good morning or afternoon, wherever you are, and welcome to this webinar organised by Resilience First. I'm Robert Hall, the Executive Director of Resilience First. For those of you who were unable to view the opening video, Resilience First's mission is to help build resilience across business communities, whether those communities be defined by geography or special interest. Please do visit our website, resiliencefirst.co.uk, to see the many projects and events we organise in an effort to help your understanding and application of resilience. We have recently formed a strategic partnership with the Resilience Shift organisation, so both extend our reach and output for the greater good. Today we are holding the last webinar of 4 in our series on the way technology can help us get to carbon net zero. Throughout the series, we have been looking at 4 discrete ways in which technology and greenery can come together, namely through adaptation, energy efficiency, renewables, and carbon capture. We're delighted to partner with Intel on this ambitious project, which will result in a white paper on the same topic for publication in May, ahead of COP26 in November. The theme of today's webinar is carbonisation in the context of the aviation sector. This is an important topic. Aviation is responsible for around 12% of carbon dioxide emissions from all transport sources and around 2% of total global emissions. In this session, we will look at innovative technical solutions which could support the attainment of the climate change goals, while ensuring that these new methods are both robust and safe, and at the same time help the aviation industry to take off again after COVID. Last week, net zero emission aviation came one step closer with the launch of a new competition to support the development of cutting-edge facilities capable of turning everyday waste into jet fuel. The Green Fuel, Green Skies competition, which is part of our Prime Minister's 10-point plan, will support UK companies as they pioneer new technologies to convert household rubbish, waste wood and excess electricity into sustainable aviation fuel. Now, offering emission savings of more than 70% compared to conventional jet fuel, these trailblazing projects will help put flying onto a sustainable path, and while helping to create 11,500 jobs over the coming decades. To help us learn more about such technological developments, and there are many more, I'm delighted to welcome 3 people who know a lot more than most about the opportunities ahead. Our keynote speaker has kindly agreed to provide us with a general overview of the role of manufacturers in this challenge, while our innovator from Velocopter will offer insights on specific technologies that will help us on our journey to net zero. To lead us through the proceedings, I would like to introduce our chair for the session, Xavier Pator, who is Account Manager EMEA at Intel Corporation. Xavier will offer some opening remarks by way of scene setting, and then we'll introduce the other speakers today. Throughout the session, I encourage all listening to ask questions of the speakers by posting brief questions in the chat box to the right of your screen. I'm sure the chair will pick up as many as he can in the Q&A session, which we will have after the speakers have spoken. Xavier, the virtual floor is yours. Thank you. Xavier, your microphone is off.
Hello, everyone. Sorry, it's an engineer who makes mistakes sometimes. 25 years ago, I was discussing with one of the CTO of a major airline company, and he explained to me that the technology of aeronautic is not following the same rule of computing. If it's happened, the plane will consume just a tank of kerosene to travel from London to New York in less than 1 hour. Technology evolves very quickly, And this is one of the key elements we want to highlight, what the technology is bringing to the aeronautics segment. During this discussion, we'll have later Samir, who will present some from ADS, is one of the his views, a keynote. And then right after, we'll have Alex from Volocopter, who will present a certain view of the technology implemented. But let's talk a little bit about carbonization. Of course, there is confidential information, so Intel is proprietary. So this is important that you have on an Intel presentation a legal disclaimer. However, everyone agreed that the CO2 emission is affecting the global climate, and this is part of the cautions of the population and the passenger from the plane. But the quality of the air is key element. It's a key element, but we have to take care of that. There is a rate slower than aviation is going up compared to the technology, compared to the CO2 increase. We know that everyone wants to travel around the world. This is a need in the market. Technology could help to reduce all the consumption, to reduce the CO2 emission. We have the aircraft technology, moderate operating improvement scenarios that's requested for 2023. Aircraft noise exposure may no longer increase, but there is an increase of the traffic. So this is where we have to keep in mind that the future aviation demand growing, and the rate of contribution of sea technology and operational improvements will continue and increase. There is two major axes that we are looking for: reduction of the consumption, of course, for the engine, what technology will bring, and of course, what are the alternative solutions for the decarbonization of the aeronautics segment. Multi-solution. We have a bunch of the solutions. The only thing we have to focus on is how we could connect the world on a substantial level, the world, to allow the passenger to travel. And this is on a common effort to create a more secure and stable environment consuming less technology. Intel will provide end-to-end solution. We have behind the transforming of the PC-centric company to address the need of the data-centric world. We are expanded our product offering to provide end-to-end solution, scaling from edge computing to the network to the cloud, and including an expanding portfolio of product to address new emerging technology and architecture, artificial intelligence, and of course, autonomous vehicle on the aeronautics segment. This is where we're going to address, and in this presentation, I will prefer to talk about reality product. So this is why I propose we go directly on the real product, on the real world. Sensing, processing, interferencing, movement, storage. It's a massive amount of data. It goes to the edge. Operating system and also operation is highly deterministic. This is one of the reasons is to reduce the cost of the maintenance, increase the rotation of the plane. This is key element. Making decision in real time and autonomously. This technology bring by Intel to help you to have this decision, without forgetting one of the key elements, securing system against cyber physical attack. We have to certify, of course, all those equipment, ensuring a safe operating in presence and to avoid fault and failure. We would like to protect the privacy. This is important. optimizing the swap, converting machine and flight computing. We have to certify solution, including middleware, including certified graphic mass library. Everyone is aware about the D0178C compliant real-time operating system. This is where we are playing an active role to be sure that the six solutions implemented could be on a plane, could be on helicopters, could be on the ground also is important. Industry-tailored firmware is key because real-time boot time could become extremely important. We ensure that we provide to the customer an engagement option for all of those technology. We have also on the ground a change of the mindset. We are seeing more and more airports are converting the surface of the building by providing also solar panel engine to optimize the orientation is coming up by the auto calculating. We have also, this is to generate, of course, some energy. Ground system. More and more plane will come on the market in the sky. We must ensure that we create a safe airways for planes. So the ground surveillance station is become mandatory. 5G is also this technology will be implemented. The appetite of the consumer to have new services on the plane, on the ground, will become bigger and bigger. So all those technology are supported by Intel, and we would like to share this vision, how it looks like this vision as today. Thank you. So the vision, the technology is evolving. We have to develop and ensuring that we provide for health and safety in the air, in the ground, by certifiable solution. This includes middleware, including graphics of the smart library, as I mentioned. We try to make the technology fully inclusive and expand all the digital readiness of the solution. This is important by partnering with you to create those new technology, by getting your feedback and providing and developing with you in collaboration new solution. We need to be sustainable. The carbon neutral is an orientation. We have this orientation in the computing to accelerate due to the change of the climate, but we have to ensure that as all together we are in this orientation. But nevertheless, we should never forget that we are enable the new technology to ensure that the progress is coming up on the market and bring a new expertise and new vision on the aeronautics segment. This is conclude my presentation, and I will transfer to Samir, who is the head of innovation and engineering at ADS. Samir, the stage is yours.
Thank you, Javier. As Javier mentioned, my name is Samir Stavani. I'm head of innovation and engineering at ADS Group, and I have just a very quick slide by way of introduction to ADS itself, so I promise not to bore you with a sales pitch. So ADS represents over 1,100 member companies in the UK, including the major industry players like Airbus, Rolls-Royce, and GKN. But actually, the vast majority of our members are supply chain companies and SMEs, well over 950 companies in that segment. ADS represents 4 major industrial sectors, which you can see on the slide, of which the largest is aerospace. And between these industries, we create significant economic value in the UK, predominantly through exports. And those are usually technology-led and innovation-led exports to make sure the UK is competitive in the global market. Priorities for ADS when we are lobbying to government and enabling our members and our companies that are part of ADS to thrive in the market are around digitalization, advanced air mobility, which we'll hear a bit more about from our speaker from Volocopter later on, and green technologies for sustainability, which is what I'll present in a bit more detail over the coming 6 or 7 slides. But of course, all of these areas are interconnected topics. So firstly, why is sustainability driving the industry? So environmental sustainability is no longer solely the remit of corporate social responsibility, but increasingly it is core and fundamental to all aviation businesses, including aerospace suppliers. If we walk around some of these charts, we can look towards a net zero emissions race going on around the world, and we expect to see more and more nations and regions committing to net zero emissions targets as we approach COP26 in November this year. And really, this is a recognition that environmental sustainability is moving out of the CSR domain and into the business as usual domain, because it delivers the triple bottom line of profit, people, and benefit to the planet. And in recent months, we've seen China's policy move towards net zero emissions 2060, which is a huge reorientation for that country, given where they were only just 1 year ago. And more recently, we've seen the US re-entering the Paris climate change agreements under the Biden administration. Again, a major reorientation, making Europe, China, and the US much more aligned in terms of their climate ambitions than they ever have been in the past. The UK is hosting COP26 this year, and so it's a huge opportunity for us as a country to showcase our global leadership, particularly in sustainable aviation solutions, where we already have some leadership opportunities. So just on the right-hand side of the slide, 3 areas. One is this year saw the implementation and the start of CORSIA, which is a global offsetting mechanism where airline and aircraft operators must offset their emissions anything above the 2019-2020 average baseline. This will, of course, create cost pressures within airlines, which will find their way into either passenger or cargo ticket prices, or into manufacturing supply chains such as those in the aerospace industry. So there is huge pressure and huge challenges as well as opportunities to reduce emissions because of this global market-based measure. In the UK, the Committee for Climate Change, which advises government on its climate ambitions, suggests that aviation, although small today, is likely to be the largest emitting sector in the UK by 2050. And this is a combination created both by the growth of aviation, which we expect to see after we get past the post-COVID recovery, but also the aggressive decarbonisation and emissions reduction efforts that we see from other major sectors, which aviation finds particularly difficult. And I'll explain a little bit why a little bit later on. And the third piece is really around growing sentiment and public pressure around aviation's need to decarbonize. So industry is taking this especially seriously, especially in a post-pandemic world. And you can start to see some of the quotes coming out from the press and the public, which just highlights and underlines where that pressure is coming from. It's very real. So for the first time, consumer, public, legislative, and investor pressure is now all aligned towards driving towards net zero emissions from aviation. So in terms of 2020s being the decade for action, I've already mentioned delivering on aviation's climate change goals is the industry's #1 priority as it seeks to recover post-COVID. The industry itself has made huge strides over the past decades to significantly reduce emissions, but there is widespread recognition that the path to net zero will have to be something different, and therefore major reorientation is required. Achieving net zero won't be easy. It involves a number of complexities, some of which I'll go through in the next couple of slides. The UK has the opportunity and is already taking a leadership position, particularly as we approach the hosting and presidency of COP26 towards the end of this year. The UK was one of the first major economies to commit a net zero emissions into law. The UK aviation industry in February 2020 published a decarbonisation roadmap, which committed to net zero emissions from UK aviation in line with a 70% growth in the sector out to 2050. And in terms of governmental ambition and strategy, the Jet Zero Council has been recently established to provide the political leadership and the coordination right across the industry and the country to help us achieve that goal. It's now time to align our actions with that ambition. I mentioned some of the complexities. So each of these boxes I could quite easily do a 15-minute presentation on, but I'll just run through what makes decarbonisation in aviation a genuinely wicked problem. Just looking at the blue box, growing pressure from the public, which matters hugely from a perspective of customers and investors. There is additional pressure to grow back better if industry wants government support in terms of investment and policy to grow back from the current pandemic and also sustain its growth trajectory well into the future. Touching on the green box, as our opening speaker mentioned, aviation represents about 2% of CO2 emissions globally and around 3 to 4% of total anthropogenic forcing through both CO2 and non-CO2 effects. Although this number is small, it could be much larger in future. And solutions cannot be formed by any one country or even region or trading bloc alone. Aviation, along with international shipping, is uniquely global, and so solutions need to be equally international in their nature. Looking at the black box, when you look at alternatives to powering flight, you start to understand why kerosene is such a perfect fuel, aside from its environmental impacts. This scenario is amplified when you see where the carbon actually resides, and the carbon predominantly is in those segments that are the most difficult to decarbonize. So you can start to understand why this is such a technical challenge. Looking at the purple box, the recovery trajectory for aviation from the global pandemic is still being mapped. Nobody has the monopoly on the crystal ball, so we all watch and predict with anticipation how the market will recover, whether we will get back to the levels of flying and growth that we enjoyed pre-pandemic. In terms of the yellow box, the science is still emerging, particularly around the non-CO2 effects of aviation on climate change, with potentially up to 2/3 of the warming effect coming from non-CO2 sources. The reason we focus on decarbonisation is that we understand carbon well, both in terms of how it's emitted, how we mitigate it, and what its impacts on the climate are. And therefore, we are right to focus on decarbonisation, but we must ensure that climate and emission science continues at pace, and we must ensure that our solutions for the decarbonisation aspects of our industry do not have any unintended consequences on the climate, such as non-CO2 effects. And finally, the red box, what we're really here to talk about today in terms of technology. There is still a lot of understanding to be gained in terms of which combinations of technologies must be brought to bear in order to decarbonize. There is lots of debate around which solutions work best, and actually there is no silver bullet. We will need a range of these combinations to come together in order to decarbonize aviation. And there is a lot of debate and a lot of analysis going on in terms of the range, solution, and economics of various solutions, whether that's sustainable aviation fuels, hydrogen, or battery and hybrid electric aircraft solutions. It's all to play for. We will need all of these solutions to form part of our net zero strategy. There are many stakeholders in the UK operating in this space. I've just named but a few here, and I won't go through this slide in any great detail because you will have the slides to view at your leisure. But just to say, there is a large number of stakeholders in the UK that is not even looking European-wide or internationally yet, a large group of stakeholders that need to be brought together to be able to coordinate their efforts towards decarbonising aviation. This is another complexity in terms of the stakeholder landscape and the amount of coordination that's needed right across the economy to achieve net zero aviation. So the way in which we are trying to do this, led by ADS, but working with partners across aviation, airports, oil and gas companies, air navigation service providers, as well as investors, is that we have started to draft a net zero action plan. So these are the key milestones that the industry believes needs to be achieved in order to meet our obligations and our ambition for net zero 2050. There is rising political ambition for the UK to be a world leader in sustainable aviation solutions, as we have been with aviation solutions in the past. The establishment of the Jet Zero Council represents a great opportunity to make a step change for a whole sector approach in this reorientation. So we've developed a high-level action plan that's available from our website, and I'm more than happy to share that over email with anyone who wants to see it, about what needs to be done to achieve this goal. And over the coming months, we look forward to working with both industry and government to implement this plan. And at the beginning of this conversation, you heard about some of the investments that have already been made around sustainable aviation fuels. And over the years, we look to do more. If we get our ambition, policy, and investments right, not only will we decarbonize aviation, but we will create a huge economic opportunity for the UK. The left-hand picture shows the aerospace companies dotted around the country. So an investment in aerospace is an investment right across the UK. The right-hand picture shows the opportunity to develop a brand new industry around sustainable aviation fuels, waste to fuel in the first instance, but in future using exotic technologies like carbon capture and storage, as well as the production of green hydrogen to develop purely synthetic fuels, so-called power to liquid solutions. And this is a fantastic opportunity to create a brand new industry and green jobs right across the UK. So in summary, tackling climate change is central to the aerospace industries and the wider aviation sector's post-COVID recovery strategies. UK aviation sees a growth scenario that is compatible with our climate goals, and we are committed to net zero 2050. There are many complexities to overcome in achieving this goal: political, engineering, as well as technology and innovation, but work is underway to define and deliver the long-term plan to get there. Now I'd like to pass back to our chair, who will introduce our next speaker, who will go into some of the solutions we might look forward to in sustainable aviation in future.
Thank you, Samir. So the first things I would like to, and I think this is a question that everyone has in top of my mind, on his mind, is when do you think the aviation will return to the pre-COVID level, and will technology help to advance this return?
Who do you want to go first, Javier?
Samir, you just start to speak.
Yeah, so as I mentioned in my presentation, nobody at the moment has the monopoly on the crystal ball. The consensus seems to be we will return to pre-pandemic traffic around the 2024-2025 timeframe. That's with all things being equal, and we see mass vaccination rollout programs and the level of appetite coming back. We know there is pent-up demand within consumers and businesses to get flying again. There are a few things which technology can certainly help with that. So for example, the digital technologies that we've all been used to, Zoom calls, exactly what we're on platforms like today, and how we will optimize hybrid ways of working. So we are maximizing that face-to-face time and optimizing those travel options in line with digital opportunities as well. The aviation industry itself is working really hard to make the end-to-end passenger experience even safer. We are seeing interesting research programs around biosafe surfaces within aircraft cabins, as well as biosecurity monitoring in airports and improvements in cabin air quality, which, by the way, is hugely cleaner than your typical office or other transport environment space, for example. So there is lots that technology can bring to the table to restart aviation and get flying back. And those opportunities are being brought to bear. The final thing I would say is, international passengers are taking off from somewhere and landing somewhere else. So those international agreements, those standards, those protocols have to be in place either multilaterally through ICAO or bilaterally between countries like UK and other destinations to make that a reality. But all of that work is certainly ongoing, and technology and innovation is certainly part of the solution.
Thank you. Alex, you want to say?
Yeah, so same from my opinion. So there is for sure a perspective out of my role at Volocopter. So where we are tackling a small aircraft, right, which enables individual transportation within the cities, which is a new segment in the aerospace area. But we have a lot of demand. We sold a couple of thousand tickets already for our first flights. We see also a lot of demand in helicopter operations in cities, for example, like New York, where you see a route ongoing since a lot of years. Okay, so and I personally think when you look into the near future, you see that new technologies are emerging, enabling us to fly safer, having more tests. And normally I'm working since months now from at home, right? But on the other hand, I had one meeting like 2 weeks ago with my team, and it's a difference, right? We all know that's a difference when we meet in person. So this will come back for sure. But I think the world after COVID will not look like the world we knew before. Okay, we will have much more telephone conferences like that. But also we are about to travel maybe more in city centers or in the direct area of our cities. For us at Volocopter, we think about a solution where you can book a flight, for example, in Germany from Berlin city center to Munich city center, and having a individual transportation vehicle, right? Instead of using a public transportation, for example, right? Really having a taxi, but you don't have to move or meet a lot of other people. You can directly within the travel zone at the airport get within 10 minutes into a Volocopter, and 10 minutes after that you are inside of the city. So the future and technologies needed to that is, yes, connectivity, right? We need mobile apps, connectivity solutions, access solutions at the airport that bring you from zone A to zone B, for example. We are a lot in talks with airports and as environmental providers there. So I personally think that there will be more and more technologies also in that space that bring you much faster from A to B. Also wearing masks, not only that, but also separating you from others. Okay, yeah. That will definitely happen, and I see a lot of discussions are in that space happening.
Yeah, I fully agree. And we expect to see the Volocopter during the Olympic Games to transport all the
I never said something about that, right?
Yeah. Coming back on this point, and this is linked for both of you, do you think biofuel or electricity will be the fuel for plane of the future?
Samir? Yeah, I'll kick off. So it's all dependent on the segment of aviation that you're using. So battery electric will be perfect for very short haul hops, precisely like the ones that Volocopter are promoting, where battery electric makes absolute sense, fast charging, ubiquitous availability of electricity, etc. For longer segments, it will probably be a hybrid electric solution, potentially using things like fuel cells, potentially using a combustion fuel, maybe hydrogen or a sustainable aviation fuel. And for the longest lengths of aviation, let's say London to New York or something longer than that, there will always be need for a liquid kerosene-like fuel, simply because of the volumetric and gravimetric energy densities that we see with kerosene today, and also the infrastructure requirements that are required at both ends to enable that, any other kind of technology. So it's never going to be is it batteries versus biofuels? Is it hydrogen versus something else? We will need a mix of these different energy solutions, but they will be far more optimized to the use case and the mission being flown, rather than expecting a one fuel fits all segments, as we've seen in the past.
Mm-hmm. So as I can tell you, the urban air mobility will for sure based on battery technology, because it's safe, it's low emissions, right? On the other hand, battery technology gets better over time. When we look at the overall mix, we have at the moment a lot of traditional Jet A powered fuel aircraft, right? But we talk about to produce that kind of aircraft like it is cars today, like there were cars today. Okay, so we are talking about 100,000 per year that we are producing of those vehicles. So the mix, when you look at the whole pie chart, right, will change, right? So of course, solutions like that will get more dominant in the market. You will see a higher fraction of the amount of used batteries as a driver for vehicles like that will emerge. So on the long run, I also see those technologies then used in traditional aircraft. You know why? Because we are now certifying at the first in the world, Volocopter, certifying an electric helicopter. Okay, so, and we are at the forefront of the innovation, and what we do is we certify the whole energy train and drivetrain solution. So, and that drivetrain solution and the outcomings out of that can be used then in traditional airplanes as well, and shorten the time of having batteries also used in those kind of airplanes. When we then talk about lithium-ion technology, right, and other technologies like graphene-based batteries and things that happen in the future, they are eventually swappable, right? So we can relatively, in a short amount of time, switch a technology from A to B, a battery technology from A to B. Okay, and also the basic requirements in thermal runaway and things will be the same in larger aircrafts than using batteries. Okay, so all the certification that happens now can be applied to larger airplanes and will speed up the process until we see hybrid airplanes, for example, that, I don't know, let's talk about the future, that switch into electric mode when they are nearby a landing zone or an airport, right, to lower the noise, whatever, right? That can happen. It can happen everything in that space, and I'm very happy to work in that space because there's a lot of innovation ahead of us and a lot of opportunity also to create cool new solutions and enable a more efficient future. Right?
Yeah, absolutely. I think that technology transfer from what's happening in the kind of smaller aircraft segment up into larger aircraft will be hugely important, because we are seeing for the first time startups and innovators able to enter the aviation market because the barriers to entry are so much lower compared to the Airbus and Boeings, where you have that kind of duopoly. So you're seeing companies like Volocopter and Lilium in Germany, but also in the UK with people like Vertical Aerospace, Samad Aerospace, and Zero Avia, for example. And so it's going to be really exciting to see how these new companies disrupt the small segments of aviation to begin with, and how they scale up to larger aviation to really compete and disrupt that larger aircraft market in future. Really exciting times.
And how do you see the challenge, the top 3 challenge to achieve the zero emission as today? Alex?
So,
or Samir?
It's the availability of the resources to produce the batteries still, because cars are now kicking into the market, and the availability of needed materials are going low, or the price gets higher, right? So one of the major cost drivers in our aircraft is already the battery. It's not only the heaviest part, it's also the most costly part. So, and we do a lot of things and very innovative things to when it comes to charging and battery management. Okay, so we have like a super low latency digital twin technology-wise in the server cloud environment, which gives us 100% in milliseconds knowledge about what the battery is doing, right? If everything works fine, but also on the work patterns that we can identify through machine learning and so on to optimize the battery usage to enable higher using cycles. So we wanted to use the battery more times, right? So until they come to end of life. So when we talk about batteries, from your iPhone, it charges only to 100%, for example, in the morning when you wake up, right? Not overnight, all time 100%, because this goes on the lifetime of the battery, right? So we do a lot of things to enable these chemistries to work perfect, right? And I think this is also something we learned a lot from the normal automotive industry, and we are using that now in aviation. When it comes to the pillars, one thing is battery technology. The other thing is getting certification for the existing technologies that are available. I think all of the technologies we know today are available for the aircraft, like the volocopter, like the VoloCity, but a lot of them needs to be certified. Okay, and this is not done already, so we need to do it. Right? I think that those two things are. I think the demand side is clear. Okay, also for regular aerospace, right? The demand side is clear, but new technologies need to be safe. And to be safe, there's a lot of things to do in testing over time, and it takes time. It takes years. We're developing already this aircraft in the 4th generation now over the last 10 years. So, and when you look into the market, there are a lot of players. They all face the same challenges. You need to go to the EASA or FAA and talk to them what technologies to use. When it comes on the 3rd pillar, maybe for the digitalization, my space, which my background is as a computer scientist. So we need to certify modems, connectivity, cloud-based server technology, talking to Intel, right? On a DAL level, that we can trust the data that we are getting from the aircraft to have business critical decisions on that data. So this is also not being done, right? The technology is there, but we need to make sure and prove that it's safe. Okay, and this will also drive much lower costs in aircraft technology that we have today compared to today. Okay.
And Samir?
Yeah, so certainly for the I guess the advanced and urban air mobility space, you know, that was absolutely exactly what we buy into. In terms of decarbonizing aviation as we currently know it, so kind of the longer haul segments, we have a 3-pillar technology strategy. So the first is around incremental improvements in core technology for the long-range aircraft, and that's propulsion as well as airframes. And that is because we know some kind of liquid fuel will be needed for the largest and the longest haul flights, and therefore, with that fuel being more expensive, it's more important to be able to use that energy far more efficiently than we currently do today. So that's core technology. Our second pillar is what we call 3rd generation technology. So these are all the advanced aircraft configurations, as well as the propulsion systems, whether they're electric, hydrogen, or hybridization. That's what we call 3rd generation technology. And that's really for that mid-range market segment that we talk about. And then finally, commercialization of sustainable aviation fuels. There are very few commentators who will say for the longest range segments, anything other than a sustainable aviation fuel. Certainly in the 2050 timeline, looking beyond that, there are probably other technologies available, but within the net zero 2050 timeframe, to really decarbonize the longest routes of aviation, you will need to commercialize sustainable aviation fuels. And I go back to that needing a global approach because it's a global market for those fuels.
And fully agree with you on this point. And we have to focus on to reduce, in fact, the fossil fuel as today, but generate enough energy for the engine to work. What is your view regarding winds and solar? Because this is one of the key elements. It has been demonstrated as a concept, the solar plane. But do you think that in the future, this technology will be interested to be implemented?
So from my perspective, I see kind of renewables being part of the energy needed to create those future energies. So for example, when you are creating green hydrogen, for example, you will need an electric source of electricity for electrolysis. And that should be a renewable source and a green source. It could be a small modular nuclear reactor, but it could just as well be solar or wind in the mix as well. Same for direct charging of pure electric aircraft. We need to make sure the end-to-end carbon journey is net zero. And so the sources of electricity that are recharging those aeroplanes and those batteries also needs to be renewable. And same for even in sustainable aviation fuels, you know, producing those fuels does require an energy source, and we have to make sure if we are to claim that that fuel is genuinely sustainable, the energy that goes into its manufacture has to be from sustainable or renewable sources. So I think there's a huge future for solar and wind to make its way into aviation, but not necessarily directly onto the aircraft. It may come via the energy source that you are producing in order to power that future aircraft.
Alex, we have a specific two questions for you. How are you going to manage end-to-end physical and digital security in mass, so anti-tampering inside the cockpit, and externally with anti-drone system or laser guns and so on? So this is the first question. And the second question is, what do emergency process in the flight failure looks like for a passenger perspective?
Mm-hmm. Coming to the first question, one of my most favorite topics, cybersecurity and aviation. We are using end-to-end encryption, high-end end-to-end encryption in the aircraft to the cloud, and also there's a whole communication and value chain encrypted. There's only encrypted communication, and things like standard things, in my opinion, things like two-factor identification and things to ensure that we have an end-to-end solution in place and can trust on the data. There's a lot of proprietary technology involved as well. When it comes to the ground, we always, when we talk about 10-9 within the urban environment, we're talking a lot about ground surveillance stations, and connectivity. So there's always minimum 3 points of truth when we talk about an information. And that's exactly what we are doing. I will not tell you more details about that. There's a lot of things which we think it's very innovative and about patent pending. But there's a lot of things happening, and this is one of the, I think, key aspects of urban air mobility. Second, safety procedures for in-flight failure. So passenger perspective. From a passenger perspective, so the aircraft always knows where to land safely. Within the urban air environment, we are talking about fixed airspace routes. And within those fixed routes, there's always at any certain point in time an emergency landing spot nearby. Okay, so and the aircraft has capabilities to identify obstacles on their own because of camera technology, machine learning that's built into the aircraft. So there's a lot of technology in the radar side within the aircraft for collision avoidance things. On the other side, when we look about the airspace and the air traffic management, the system that we are planning is also incorporating other vehicles in the airspace, identifying those other vehicles, including smaller birds. At the end of the day, I wanted to know every colibri that flies through the air corridor, right? And recognize it and react on that. So this technology is already there. It's very expensive at the moment. We are helping together with Intel to make those technologies more available and affordable.
We have many questions, and I want to take one last question for us. So aside from aircraft and fuel technology improvement for the aviation industry, so everyone is aware about that, is going on this. There is maybe other flag points that the industry and the supply chain need to be addressed, and to go on to net zero carbon or carbon-free technology. What are this technology will be implemented outside the plane?
Yeah, so there are still around 10% of emission savings to be gained from operational improvements. So airspace, both upper airspace and lower airspace redesign to make sure we avoid things like stacking and queuing. Those are great opportunities, and they use a range of digital technologies to make that happen, right, in terms of collaborative decision making, air navigation services, etc. So that's a huge opportunity. And we mustn't forget that airports need to adapt and be given time to adapt to embrace these new forms of aviation. And so really the standards and the configurations of the future aircraft, what kind of charging plug will they use? Will that be standardized? All of this needs to be communicated with the airports quite early on. Otherwise, they will naturally be the bottleneck for this new dawn of aviation, unless we can engage with them early and allow them to adapt early enough.
Okay. Thank you. And we're going to stop here because we have many questions. So we try to do our best to reply. And I take over. I leave to Robert the hand to close this session. Thank you.
Thank you, Xavier. It's been a fascinating session, and we've covered a lot of ground, and I'm sure we could have gone on much longer. So it leaves me really to say on behalf of Resilience First and all who've listened, thank you very much to the chair and the speakers for their contribution today. Thank you also to ADS Group, British Aviation Group, Institute for Engineering Technology and the Resilient Shift for supporting the webinars. And we will summarise the event and circulate in due course. And please do join us for our next webinar, not in this series, which will be on the 20th of April. Finally, I'd just like to remind you, particularly those in the UK, that at 12 o'clock, which is just about upon us, we have a minute's silence in this country for the National Day of Reflection, to mark the nation's first lockdown and the lives lost in the past year. So I will close and say goodbye and hope you respect the minute's hour. Thank you. Bye-bye.
Thank you.